Okay, so this is going to be a video on the FP1 test I did with my further maths class on transformation and matrices. A lot of you found it difficult, and particularly the last question, so I'm going to go through it reasonably slowly and try and cover some of that particular chapter while we do it. As usual, you've got to keep working at these things and to improve, so please work through this with me rather than just watch it. So we've got M is a matrix that produces a reflection through y equals minus x, followed by a shear with k equals 2 parallel to the y-axis. We've got to define M. So M is going to be a combination of two transformations, P followed by Q. Now notice how I did it that way around. P is going to happen first, then Q. So if we have a coordinate which we define as a vector, x, then and I'm going to perform that transformation, then I'm going to do px followed by q in that order. So P followed by Q. Now a lot of students get that wrong because they read it as QP, Q being the thing you do first. It's not true, it's P. Which means P is the first thing that's going to happen, and that's going to be the reflection. We're going to define then a reflection through the line y equals minus x. Now on your green formula booklet that you get given at the beginning of every exam, there are two transformation matrices that you were given, rotation and reflection. So you don't need to learn these, but I would recommend that you try to, because it will help you spot them in other problems. So what I'd like you to do is to write down the standard reflection matrix, please. So pause the video. Okay, so hopefully you got cos 2 theta, sine 2 theta, sine 2 theta, and minus cos 2 theta, where theta is the angle that the line makes with the x-axis as in the anti-clockwise direction, and that is often given as y equals tan theta of x. So m equals tan theta. So if you're given the equation of the line, then you can work out the angle which you have to substitute into this standard reflection matrix. Now in this particular case we've got the line y equals minus x. So if I sketch that here, this is the line y equals minus x. You should all be able to sketch that by now. And that angle there, theta, is 135 degrees. Now I'm working in degrees. We can work in radians at this point. But if I'm working in degrees, then when I substitute the values into this matrix, then my calculator must be set in degrees. If I'm working in radians, then my calculator must be set in radians. It doesn't matter whether you're working in degrees or radians, but you must have the calculator set appropriately. So now to work out P, which I'm calling the reflection matrix, it's going to be cos of 2 of those, which is 270, sine of 270, sine of 270, minus cos of 270. And now if I put that into my calculator carefully, and you should be able to do the same, making sure it's on degrees because I'm using degrees, and I get 0, minus 1, minus 1, 0. And I've got marks in my further pure exam. So that's the reflection. Now I've got to do the shear parallel to the y-axis with a scale factor of 2. Now there's some other transformation matrix that you will have to learn. You'll have to learn stretch parallel to the x, stretch parallel to the y, shear parallel to the x, shear parallel to the y, enlargement, which is a stretch in the x and the y, as well as the rotation and the reflection. So can you please write down what we're calling Q in this case, which is a shear parallel to the y with a scale factor of 2. Okay, so we get 1, 0, 2, 1. Now if it was a stretch, then we change the values, these two values, this one to make it a stretch in the x, this one to make it a stretch in the y, but as it's a shear in the y, we change the 0 to be the scale factor we're looking for, which in this case is 2. So that means we've got P followed by Q. So M is going to be 1, 2, 0, 1 multiplied by 0, minus 1, minus 1, 0. So that is a reflection followed by a shear. Now be careful, because it doesn't always give the same answer, and remember that multiplication of matrices is not commutative, which means you have to be careful on the order that you multiply them. And when you multiply that out, you get 0, minus 1, minus 1, minus 2. And that's the answer to the first question. Now please don't start using your graphics calculators for a simple 2 by 2 multiplication. 2 by 2 matrix multiplication. It takes longer than actually just quickly doing it in your head. If you're really nervous, you can always check it if you have a time at the end. Okay, so if you're a bit worried, then just put a little star next to it so you know you can come back and check it at the end if you have time. Because one thing you're going to have to struggle with in FP1, as well as the material, is the time that you have to do all these questions in. Right, so moving on to question 2 now. Okay, so we have a parallelogram with one vertex at the origin, and it has an area of 8. It is transformed by this matrix. Write down the area of the image parallelogram. This is a bit of a gift of a question. Now we should know that the area scale factor is equal to the determinant of the transformation matrix that you're mapping onto the object to get the image. So if we take the object and we perform the mapping of M to get the image, then the area is going to be whatever the original area was, A. The area of the new shape is going to be determinant of M lots of A. Now remember, there's different ways that you can write determinant. It's det M, M, or M. But the thing is, it's got to be the magnitude that we're worried about. So if this M comes out to be a negative, then we multiply by its modulus. It's the magnitude we're looking for, but we will know that the sense of the enlargement is changed. Okay. So in this case, then we've got 8 lots of whatever the magnitude of the determinant of M is. So now we have to work out whatever the determinant of M is. And we're going to take its modulus, its magnitude, not worry about if it's a negative or positive, the area scale factor. So the determinant of M is going to equal, well you work out what the determinant of M is, please. If M equals 4, 2, minus 4, 3, you work out the determinant of M carefully and pause your video. Okay, well 4 3s are 12, and negative 4 times by 2 is negative 8, so we're left with 20. Okay, be careful when you're doing determinants with the negative numbers. It's a shame to drop a mark on an easy question. So we know that the area of the image is going to be 8, because that's the original area, times by the modulus, magnitude of the determinant of M, which is 20, so it's going to be 160. So the area equals 160. A nice easy 2 marks in an exam. On to question 3 now, and we've got a matrix 5, 10, negative 3, negative 8 transforms the point xy to the point x prime, y prime. So this is the object, this is the image, and they give you the transformation mapping there, So we know that x prime, y prime is equal to 5, 10, negative 3, negative 8, x, y. And we've got to find the exact values of M, if they exist, such that all points of the line y equals mx transform to points which are on the line y equals 2mx. Okay? Now, if you think about what's going on here, all the points have to be on the line y equals mx, and they've got to transform onto a line with y equals 2mx. So if we look at the relationship inside here, we should know that when x is x, y is going to be mx. So we can write this as 5, 10, negative 3, negative 8. And we get x, and y is going to be, well, m lots of x. Because don't forget that y is the same as mx. And if we look at this answer, we're going to get x prime, so all the points, and we were told that it's going to be what, y prime 2m lots of x prime. Because it's going to sit on a line y equals 2m, but in this case we're substituting x prime in, so we're going to get 2m x prime. So there's our equation that we have to solve. And we're going to find the values of m that satisfy this equation. Now at the moment it might not look like you can solve it, but if we just have faith and we multiply out the right hand side, we get the following. Well, you do it. You tell me what you get after you've multiplied out the right hand side. Pause the video. Okay, well you get 5x plus 10mx, and you get negative 3x minus 8mx. So that means that x prime must equal 5x plus 10mx, and 2mx prime must equal minus 3x minus 8mx. So we've got a simultaneous equation here which we can solve for m, because it's n that we're interested in. So if we substitute in this x prime 5x plus 10mx here for the x prime there, then we get 2m 5x plus 10mx equals minus 3x minus 8mx. Now multiply out the left hand side and see what happens. And you should get that. Now just check that you have the same thing. Now terms is a common factor of x in each of the terms. So we can divide every term by x. So that term, that becomes 1, 1, 1, and 1. Remember, if you're going to cancel, you've got to do it, there's got to be a common factor in every term. Same in fractions. If you're cancelling above and below the fraction line, there's got to be a common factor in every term that you can divide by. If you're not quite sure on how to do that, then have a look at my video on simplifying algebraic fractions on the How to Do Algebra playlist. Right, so then we're left with 10m plus 20m squared equals minus 3 minus 8m, which is a quadratic equation thus. So now solve that quadratic equation. Pause your video. Now there's a few ways that you can do this. You can complete the square, but it's a tricky complete the square question. You can try and factorize it, but this one doesn't factorize, or you can use a formula. It's up to you. Now just for fun, I'm going to complete the square, and just to show you again a little bit of an aside on how to complete the square when it's not quite so nice. So the first thing I'm going to do is going to factor out that 20. Okay, and then I'm going to complete the square of this thing inside this bracket. Okay, I'm going to complete the square of the thing inside that bracket. So I get 20 m plus 9 over 20, because I'm halving the coefficient of x, all squared, minus 9 over 20, which is 81 over 400, plus 3 equals 0. So I've squared the numerator and the denominator. Always leave your fractions and leave your non-whole numbers as fractions, because it's much easier to square and square root them than it is to do decimals. But you are allowed a calculator in core in FP1. Now we multiply that 20 back in. And then we work out what minus 81 over 20 is. Now that's going to be 81 over 20 plus 60 over 20, because 3 is 60 over 20, and I've made the common denominator now, which is going to give me 20 m plus 9 over 20 squared minus 21 over 20 equals 0. So m plus 9 over 20 squared minus equals 21 over 400, because I've added 21 over 20 to both sides, so divided by 20. So m plus 9 over 20 is going to equal the square plus or minus the square root of 21 over 20. I've square rooted the numerator and the denominator. The denominator is a square number, so I get 20. So m equals minus 9 plus or minus the square root of 21 over 20. Now you can use a formula, and you would have got the same answer if you used the formula. Just try and simplify your surd when you do that. But I did it by completing a square just for fun, and also it might help you when you're doing completing a square in Core 1 to see how I've done that. So that's a good little aside. Right, so there are the two values. We've either got when m is minus 9 plus root 21 over 20, or when minus 9 minus root 21 over 20. And they are the two exact values. And it did say to give the exact values. Okay, so if we look back at the question, it says exact. Where are you? Exact values. So they're not looking for a decimal approximation. So be careful about using your graphics calculators to solve that quadratic equation. Some students get lazy. If you try using your graphics calculators, most of them will have worked that out to a decimal approximation, not an exact answer. So if it says exact, you have to use the formula, but then leave your answers as a surd, or better still, complete the square. That leads us to question 4. And question 4 was the hardest question on the test, and it is meant to be quite testing. So what we've got is we've got a 2 by 2 matrix. Matrices R and S represent the following transformation in the xy plane. So the R is a rotation through an angle theta, anti-clockwise about the origin, and S is a stretch with a scale factor of 2, parallel to the x-axis, with the y-axis invariant. What it means by invariant means that it doesn't change. Right, so, and for 2 marks, it asks you to write down the matrices R and S. Now, one of those marks is the easiest mark you're going to have on your FP1 paper, because you're given that anti-clockwise transformation rotation matrix in your green booklet. So can you write down the answers for R and S? R is the rotation, so that's going to be cos theta minus sine theta cos theta. So that's the rotation, and the stretch S parallel to the x is going to be 2, 0, 0, 1. If you don't know that, you have to learn it. There's certain things you have to know and you can't avoid, so you just have to get on and learn it. So they are the transformation R and S. Now it says the matrix RS inverse of R is denoted by M, and it's asked us to show that M is that for 4 marks. So the first thing I'm going to do is work out the inverse of R. Now to do that, I will need the determinant of R. So the determinant of R is equal to, okay, you should have got cos squared theta minus sine squared theta, because you get cos times by the cos to get cos squared theta, and you get the sine times by the minus sine. You get the sine times by the minus sine to get minus sine squared theta. So you've got the determinant of R as cos squared theta plus sine squared theta, which is equal to 1, which you've learned in Core 2, or you've learned in Core 2. So the inverse of R is going to be 1 lot of cos theta sine theta minus sine theta cos theta. Because remember, when you find the inverse, you times the determinant, and you change the positions of A and D, and you change the signs of B and C. So that's the inverse of R. Now we've got to find M, and we've got to get the order correct. So we've got to work out cos theta minus sine theta, sine theta cos theta. We're going to multiply that by 2, 0, 0, 1, and then by cos theta sine theta minus sine theta cos theta. Now you may have noticed that at the beginning when I started writing that down, I think I got that negative too close to that term in that element of that matrix. So I decided to make my matrix slightly bigger, because it is a 2 by 2, not a 1 by 2. So be careful not to make the matrices too small. And just generally, don't worry about making your workings too small. I'm making it quite big here because it's on a video. But in my answers, it's not going to be much smaller than that, because what you don't want is the examiner just try to work out little minute writing to see whether you've made a mistake or not. Don't think you can get away with mistakes because you write it small. Okay, they will use magnifying glasses or zoom in if it's been scanned in, so just try and make their life easier, make other mathematicians' life easier by writing a slightly larger if you're a tiny writer. Now we have to multiply those out. Now it doesn't matter if we multiply this matrix by this matrix, then multiply by that one, or do this by that, then whatever this is, times it by that. So it doesn't matter in that respect once you have the order of the matrices lined up properly. So multiply those out. Okay, well if you just multiplied it straight without doing any simplification, you'll get to that step there. So I've multiplied these two matrices first to get that matrix. Just check that's if that's what you've done. If you've done it the other way around, you're just going to have to interpret your answer. And then I've multiplied these two matrices together to get this quite complicated looking matrix. Okay, it's still a 2 by 2. Should have made it slightly bigger after what I said because of the length of the terms. Now we've been given a target of that. So we've got to be thinking, how are we going to turn what we've got into that? Now I wouldn't in an exam just write down that next line thinking and go da-na, because you've got to show an examiner you've understood why that's the case. So let's just look at it a bit closer. Now in this problem here we've got 2 cos squared theta plus sine squared theta. And if you write that out again just down at the bottom here, but instead of writing 2 cos squared theta plus sine squared theta, we can write that as, that's identical to, that's the same as cos squared theta plus cos squared theta plus sine squared theta. Okay? Because 2 cos squared thetas are just the same as cos squared plus cos squared theta. Now that cos squared theta plus sine squared theta becomes a 1. So you're left with cos squared theta plus 1, which is what you were wanting to show, but just the other way round. 1 plus cos squared theta is the same as cos squared theta plus 1. And the same thing works here with this term at the bottom right hand corner, the bottom element down here. Now if you look at the other two elements, if you've got sine theta cos theta, 2 of them, take away 1 sine theta cos theta, that leaves you sine theta cos theta, and the same here. Now cos theta sine theta is the same as sine theta cos theta, because order of multiplication doesn't matter. So that means that we can then write 1 plus cos squared theta sine theta cos theta sine theta cos theta 1 plus sine squared theta, which is what we were asked to show. So I'm going to put a QED there and box it up. Now I would, on my answer, make sure that that step there was clear, so that my understanding of how I've gone from this line to this line is clear, like as an aside somewhere. The last part of the test is a little bit more complicated, so let's take our time over that. We're given that the point P has a column matrix xy, so the coordinate xy, and the point Q is the image of P under the transformation of M. Find the column matrix of Q and hence show that the line joining P to Q makes an angle theta with the x-axis. Q is MP, where Q is a transformed P following the mapping of M. So I can write that as x prime y prime, and M is the transformation matrix 1 plus cos squared theta, sine theta, cos theta, sine theta, cos theta. While I'm finishing that off, this is one of those important questions where if you couldn't have done the whole of part 2, you can still do part 3. So don't give up on a question. You can still keep going and see if you can get as many marks as you can out of the question. That's what our new point's going to be if we multiply that matrix by our initial point P. So that's the object and that's the image. So carefully multiply those out and see what you get. And you should have got that. Now be very careful with this, because when you multiply 1 plus cos squared theta by x, both of these terms in 1 plus cos squared theta must be multiplied by x. So you either put a x lots of with the bracket, so you either write it like that, or you expand the bracket in one step. But make sure both terms are multiplied by x. And also we have got just 2 elements now. It's not a 2 by 2, so I've written this closer to this to make it look like one element. So what we're saying is the x coordinate of the image is going to be that complicated expression, and the y coordinate of the image is going to be that complicated expression. And it asked us in the question to show that a line joining the object and the image produces an angle theta with the x-axis. So in doubt, you should just try and draw a picture. So we've got P and Q. Okay, P and Q, the object and the image. And with the x-axis, it's going to make an angle theta. We've got to show that that's theta. So let's just call it alpha for now, and see if we can show alpha. We can call it anything, any any unknown, but let's call it alpha, and let's see whether that alpha is the same as theta once we've worked it out. Now, that P is going to have a coordinate of x, y, and that Q is going to have a coordinate of x prime, y prime, which we've worked out is this rather complicated expression here. And we can make that into a right angled triangle. And this okay, so what we got then is what we're going to try and do is work out alpha and show that that's equal to theta. Now we know that in this straight line, in any straight line, that the gradient of the line is equal to the change in y, which is going to be that length there, y prime take away y, divided by the change in x. And in terms of trigonometry, that's the same as the opposite divided by the adjacent side, if that's the angle defined here as alpha, which is the same as tan alpha. So if we can try and show then by a number of algebraic steps that alpha equals theta, then we are done. So tan alpha equals, well, y prime is x sine theta cos theta plus y sine squared theta, and take y away from that, and x was x plus x cos squared theta plus y sine theta cos theta, and we've got to take away x from that. Okay, so the first bracket is the image, is Q, which we worked out here, and we're taking away the object, P. Now if we look at that carefully, you'll see that the y there and take away that y there gives us 0, so we're left with x. I'm just going to x sine theta cos theta plus y sine squared theta, and the same thing happens in the denominator, that x and that x subtract, and we get y sine theta cos theta plus x cos squared theta. I've just changed the order, so don't panic, I've just changed the order around. Now what we've got to go from there is to show that alpha equals theta. Now even if you can't do that last step, you've probably got all but 1 mark in your FP1 exam, on this question, which is doing well. But what we've got to do is see if we can simplify that right hand side, simplify this fraction. Now I've recorded a video on simplifying algebraic fractions, and I've recorded it and I've put it into the how to do algebra playlist, and I strongly recommend you go and watch that, because at this point we see all sorts of mistakes. Students saying, well, that sine can cancel with that sine, for instance, and that cos can cancel with that cos. But that's not how you simplify algebraic fractions. If you're going to divide a term in the denominator by, say, sine theta, you have to divide every term in both the numerator and the denominator by sine theta. And you can see this term doesn't contain a sine theta, so that won't actually simplify. That will become more complicated. So you've got to be very careful when you're cancelling algebraic fractions, that you do it correctly. Now, there's not a single term in here that all have the same common factor. This term does not include sine, this term does not include cos. So we can't cancel that straightforward. We're not allowed either to cancel the x there and the x there, because this term doesn't contain x. So you might be thinking then we're lost at this stage. But when you're simplifying algebraic fractions, always look to see if anything will factorize. So looking at the numerator, there's a common factor there of sine theta. So we can factor out sine theta, and we'll get left behind x cos theta plus y sine theta. And then let's see if we can factorize the denominator. And again, it's a common term of cos theta, so we can take the cos theta out. And that gives us y sine theta plus x cos theta. And again, you might not have immediately realised why that's made it more simple, but if you look here, we've got x cos theta plus y sine theta, and we've got x cos theta plus y sine theta. So now we do have a common factor in the two terms above and below the line. This is a common factor. So if I divide the top by x cos theta plus y sine theta, I get 1. And if I divide the bottom, I also get 1 by the same factor, the same number. So what I'm left with is tan alpha equals sine theta over cos theta. But that sine theta over cos theta is equal to tan theta. So we know that alpha must equal theta, and that's what we were asked to show. Okay, so that's quite a complicated last part to that question, and it requires you cancelling fractions correctly. Now, if you can't cancel algebraic fractions, you're going to really struggle with that last part. So I recommend you don't get too proud, and you accept you've got an issue there, and you go away and do some work on those. Come and see me if you still can't do that. I can give you sheets of questions where you have to cancel algebraic fractions and do algebraic fractions. You will need it all the way through your A level, and it is something that we tend to assume you know how to do because we studied it at GCSE. But my experience is students can get a GCSE A star or grade A without actually getting this understanding correct, but they it can still be hidden. This flaw can be hidden away even with students that get A stars.